So the difference between an open system and a closed system is really whether or not energy can leave the system or not. So in an open system, energy can leave or enter the system, whereas for a closed system, we essentially have that delta E for the system is equal to 0. What this really comes down to is whether or not there's something in the surroundings exerting a net force on the system. So that's why it's very important to define the system and the surroundings and then draw a free body diagram for the system. If there's something exerting a net force on the system, you no longer have a closed system. You're going to have energy transfer into or out of the system. Now, how we define our system really can vary, and it shouldn't matter how we define our system. Some choices of systems will make the things a little bit easier than others, but energy is going to be conserved overall no matter what. So let's take an example. This is the example from the book where they talk about a woman who is lifting a barbell through some distance h and trying to find out what exactly is the final kinetic energy. So if we just consider the barbell to be our system, is the barbell, then the surroundings are the woman and the earth. So what we can do then is draw our energy bar charts for this. We've got K initial plus the work done is equal to K final. So here we're assuming that the barbell's initially at rest, so we don't have any initial kinetic energy. In this case, both the woman and the earth are doing work on this system. So we would actually have two terms involved in the work. One coming from F times that distance h, the other one from the force of the earth on the barbell, which we can assume to be mg times h. Now, since the woman is lifting it up and actually speeding it up, we know that the work that she's doing is larger than the work done by the earth, so we're going to have some positive net work done, and from energy conservation, that's all going into final kinetic energy. And so we can find the kinetic energy of the barbell that way. As another example of a system, let's go ahead and consider the barbell plus the earth to be my system. The barbell plus earth. In this case, the surroundings are just the woman. And so if I draw my energy bar chart, I've got K initial plus UG initial plus the work done is equal to K final plus UG final. So again, we're going to assume that the barbell starts at rest, so we now have no initial kinetic energy. And let's also, just for simplicity, take our starting height to be 0, which means we'll have 0 gravitational potential energy. So the woman is going to do some work. Now, when we calculated this work before, it was the work done by her and then the work done by the earth, which was actually negative. So in this case, when it's just the work done by the woman, we're going to have quite a bit more work done. But on this side of the equation, we have to take into account that change in gravitational potential energy, and the difference is just going to be K final. So these two should be exactly the same. The K final is the same. Now, a third choice of system we could make would be to have everything in the system. Now, the problem with that is we don't have a potential energy function for the woman. What we are told is the force that she exerts. So even though we could do this, it doesn't help us actually calculate what that kinetic energy final is. What we would have to do, as the book does, is consider the energy, the internal energy of the woman. And that's not something that's really easy to calculate. So although we could choose this as our system, since we don't know how to calculate the internal energy of a human being, we really don't want to do that in terms of calculating kinetic energy. So either of these two choices would work out. And so that's really kind of the idea here. Now, one thing you really want to avoid is double counting. That's really kind of the key idea in this section. Because if we choose this to be our system, the barbell plus the Earth, you don't want to include a term of the Earth doing work on the barbell. That would end up double counting the effect of the Earth. Either something is inside the system and has potential energy associated with it, or it's outside the system and it does work on the system. Be very careful that you pay attention and don't end up double counting the effects of a certain object.